Hello everyone. In this lecture, I shall introduce the vector calculus. So, saying the calculus, what do you mean? Means you are given a continuous function, right? You find its derivative, you find its integration, also the limit. So, this limit, derivative and integrations together are the calculus, right? Basically, it deals with the continuous function. Now we extend this study to the vectors, okay? So basically here we will discuss the derivatives, subsequently the gradient, and as an application point of view I shall discuss the directional derivative, and in the subsequent lecture I shall discuss the divergence and curl, okay? So now my intention is to extend this calculus, means we find the derivative of the scalar and vector point functions. Also we will introduce the vector differential operator, okay? So now what is a scalar point function and what is a vector point functions? Basically, what do you mean by a point function? Point function, a function that assigns a value, right? You are a function that assigns a value. The value may be a real number or the value may be a vector, okay? If it is a real number, then it's give you the scalar point function. If it's a vector, then it will give you a vector point function. So you see you are given a point function. Fp is a point function. It can be classified into two parts. One is the scalar point function, other one is the vector point function. So the scalar point function means earlier what we know, the limit, continuity, derivative of the function. These are basically the scalar point functions, okay? So the scalar point function here, I write it, suppose fp is fxyz in space, in RQ, three-dimensional space, and subsequently the vector point function vp will be, right, v1p, v2p, v3p, or this is I can write v1i plus v2j plus v3k, okay? This is a vector point function in RQ, right? So before the details of discussion, let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, Visut, Burla, Odisha. So without much delay, let us discuss the details of this point function, scalar point function, vector point function, gradient, and the application of the gradient. So directional derivative is one of the major consequence of the gradient. So as I have pointed out, the scalar point function, it assigns a real number or a scalar, okay, to each point in the given region or space. For example, the temperature at any point in a room, the pressure at any point in a field, the density of a solid body. These are all the examples of the scalar point functions. Similarly, the vector point functions, this assigns a vector to each point in the space or in the given region. For example, the velocity of a fluid at a point in space, the electric field at any point, the force acting on a body, etc. are the examples of the vector point function, right? Now this scalar point function and the vector point function, right, defines the field. Scalar point function defines the scalar field and vector point function defines the vector field, okay? Now let us discuss the vector differentiation. Then we will introduce the vector differential operator to carry forward our study of gradient, divergence and curl. Now coming to the vector differentiation, consider a space curve. In RQ, right, in three-dimensional space, means you are given here x-axis, y-axis and z-axis, and suppose you are given a curve like this. You are given a, suppose this is a C is a curve here. Now let P be the, so consider C be the space curve. C be the space curve. Now let P be the point. P be a point on this curve C. And this Q be another neighboring point. Q be another neighboring point here. Okay. So let this position vector of this P here is my RT. RT. Okay. The position vector of P. Now the position vector of P. Position vector of P be here RT is equal to XTI plus YTJ plus ZTK. Okay. So here T is a scalar variable or parameter. Scalar variable or parameter here. Now as T changes, okay, this point P describes the curve C, generates the curve C. Okay, let Q be the another neighboring point. Let Q be the another neighboring point, and the position vector will be similarly R plus delta T. Now by the vector law of addition, this chord here, okay, this chord here, by the vector law of addition we can have the curve. The chord is given by here this difference of these two, okay, or I call it here del R is equal to here R T plus delta T minus RT. Okay, RT. So this is here del R. Okay. Now this P creates the curve C as T changes. So that the position vector of the curve be, let the position vector, let the parametric representation of C, not the position vector, let the parametric representation of C, let the parametric representation of C be here RT is equal to XTI plus YTJ plus ZTK. So P and Q are two neighboring points. Now as Q tends to P, okay, as Q tends to P, what we can write here, del R tends to 0, right? Del R tends to 0. So we write del R by, as Q tends to P, we write here del R by del T is equal to R T plus delta T minus RT divided by delta T. As delta T tends to 0, limit delta T tends to 0, okay, limit delta T tends to 0. So this will give you the dr by dt, okay, dr by dt. So dr by dt is a vector here, is a vector along the chord PQ, and it is in the direction of tangent at P. If you draw the tangent at P, it should be in the direction of the tangent, in the direction of the tangent at P, okay. So consequently here dr by dt or your r dash t means, you see this is your RT, okay, this is your RT, okay, this is your RT. So this is the RT, right, position vector of the curve here. So now this r dash t means we just differentiate it component wise, okay. So differentiation of this component wise, here x dash ti plus y dash tj plus z dash t k. So this is equal to, I can write dx by dt I plus dy by dt j plus dz by dt k. Okay, so that means here dr is equal to dxi plus dyj plus dzk, right? Dzk. In this way we will write. So as you see here, this derivative with the single parameter t is nothing but it is component wise derivative. Component wise derivative, right? For example, suppose if I consider one example, for example, if your r is given by this with the single parameter t, then here r dash or dr by dt, here dr by dt, the derivative will be simply, the derivative of this is 3t square I, the derivative of this is 6tj, and the derivative of this is plus 2k. This is the ordinary derivative component wise. Now the moment t is time, okay, the moment t is time, then it represents the velocity vector, okay. Then this dr by dt is nothing but the velocity. Dr by dt is the velocity with which the point moves along the curve, okay. So this is the interpretation. Now this r is a function of single variable. Here r is a function of single variable. Now this can be extended it to partial derivative, okay. Partial derivative. If here r is a function of x, y, z, okay, three variables, then we can create here rx, we can find rx, ry, rz, the partial derivative we can find. Means here changes in x, y and z are constant. We can write here limit del x tends to 0, okay, del x tends to 0. Here the changes will be in x, here r of x plus del x, okay. So changes in x, here y and z, minus r x y z divided by here del x. So here the changes in x. Similarly for ry, it is limit del y tends to 0, r of here x, y and z. So here changes in y only, and z minus r x y z, okay, divided here by here del y. Similarly here rz will be limit del z tends to 0, r of x, y, changes in z minus r x y z divided by here del z, okay. The usual partial derivatives. Now if r is this, a function of x, y, z here, now three variables, then what will be your rx? Differentiate this with respect to x, treating y and z constant. So it will be 2y square z I plus, so here it is with respect to x partially, it is 6x, okay, 6x y cube z square j plus, differentiating this, it is 4yz k. Likewise here ry will be 4xyzi plus 9x square y square z square j plus 4xzk. Similarly here rz will be, treating x and y constant, 2xy square I plus 6x square y cube z j plus 4xy k, okay. So usual derivative, usual partial derivatives, but component wise we are taking the derivative, okay. Now coming to the properties of the differentiation, here I have considered 3 vector point function and 1 scalar point function. If I take the scalar point function only, then the properties will same as the previous what we read in year plus 2 or 12th standards, okay. So now while we are considering the vector, the order matters, right? That's why there will be a little change. So we have the properties. If we take the addition of two vectors u plus v, then it is individually d by dt of u plus d by dt of v, right? Now if d by dt of, I am taking phi u. Now phi is a scalar point function, not a constant. Then again the product formula, phi du by dt plus dv by dt. Okay, so phi is, if I am taking d by dt of ku, then k will be taken out, d by dt of u, but phi is a scalar here, phi is a scalar point function, right? This is the change here. So now likewise here d by dt of u cross v, okay, u cross v. So now it is u cross dv by dt plus du by dt cross here v. Okay, so this order matters here, this order is strict, because a cross b is not equal to b cross a. Okay, this order is strict. Likewise here, suppose d by dt of, I take ku, then it is simply k taken out, d by dt of u. Likewise we have, so you see here product of three functions here, right? So derivative of one keeping other two silent, again the derivative of another one keeping other silent, in that way. So here no matter of order doesn't matter. Okay, order doesn't matter in dot product here, Now here order matters, order is strict here. Okay, order matters, we cannot reverse it as I mentioned. Now coming to the vector differential operator, it is denoted by this. Okay, we read it nabla or inverted del or nabla, right? So what is that? So this del here is I cap del by del x plus j cap del by del y plus k cap del by del z. Okay, so this is the vector differential operator. Now this vector differential operator, or in short I can write it summation of I del by del x, or summation of j del by del y, or summation of k del by del z. Means only del by del x is given, summation is given, means suppose we are talking about rq, means y and z are there. Okay, so now coming to the properties of the vector differential operator, if it operates on the scalar point function and vector point function, it yields your gradient, divergence and curl as follows. Suppose you have your del here, now if this del is applied over a scalar point function, over a vector point function and over a vector point function, suppose here f is a scalar point function here, f x y z is a scalar point function here, and it defines here grad f. Grad f means what? Here del f is a scalar here, and you can write it del I del by del x plus j del by del y plus k del by del z f. Okay, so that means your this differentiated partially, so it is fxi, I can write fxi plus fyj plus fzk. Okay, or in short I write it summation of fxi. So here, as you know, if del is operated on the scalar point function, okay, this is scalar point function, then it yields the gradient, it defines the gradient. So gradient of f, or I write del f, so it is this. In short I will write it, it is summation of I fxi in short, or I write summation of j fy, or I write summation of k fz in short. Okay, so now coming to the divergence. Here if V is a vector, here V is a vector point function, then it defines the divergence here. Here div V is your del dot V. Okay, del dot V. Here del is a vector, here F is a scalar, here this is the similar to the dot product. And here if this V is a vector and call V, it will give you the cross product. It will give you the cross product. Okay, it will give you the cross product, right? So this will be, if I find div V, then it will be your div V, right? Your div V will be equal to I del by del x plus j del by del y plus k del by del z in dot product v1i plus v2j plus v3k, right? It will give you, it is dot product of two vectors, so it will simply del v1 by del x plus del v2 by del y plus del v3 by del z. It is simply a scalar, right? Dot product of two vector, it is simply a scalar. Or I can write it, for symbolic point of view I can write it. It is simply summation of I cap dot del f by del x, del f by del x. Or I may write it summation of j cap fy, or I may write it summation of k cap dot fz. So here dot product is there. Now for your call you have, it should be, it is call of V is equal to summation of I cap cross f del f by del x, or I may write it summation of j cap cross del f by del y, or I can write it summation of k cross del f by del z. But if I want to evaluate it analytically, it will be here I del f by del x plus j del f by del y plus k del f by del z cross product v1i plus v2j plus v3k. It will give you cross product of two vector. It is I j k del by del x del by del y del by del z, and it is v1 v2 v3 determinant. So therefore your call v will be this much. Okay, call v will be this much. So now the details we will discuss in the subsequent lectures. For divergence and call we will discuss in the subsequent lectures, but here we will concentrate on the gradient. So as you see here, gradient defines a vector field. So the answer is a vector here, but here it defines a scalar field. Okay, you see dot product of two vector is a scalar, it defines a scalar field. It defines a vector field. Cross product of two vector is a vector. Now coming to the properties. Properties of gradient. You see, since we see this gradient here is fxi fyj plus fzk, so the properties will work in the direction of the properties of the derivatives. The properties are as follows. Your grad f plus g is grad f plus grad g if it is minus and minus, in line with the properties of the derivative. Property number 2, grad kf constant, k is a constant, k taken out grad f. Okay, property number 3, grad fg, it is in line with the product of two functions here, f grad g plus g grad f. Then your property number 4, here grad f to the power n, your derivative of x to the power n and x to the power n minus 1, in that line nf to the power n minus 1 gradient of f. And 5th, grad f by g, so this will division formula, 1 by g square g grad f minus f grad g, second derivative first minus first derivative second by second square, and here g should not equal to 0. Okay, so these are the properties. If we prove them, coming to the proof 1, right, here grad f plus g, you can write here summation of I del by del x f plus g, in short you can write it. So that is equal to summation of I del f by del x plus del g by plus summation of I, you split them, summation of I del g by del x, is not it? So because it is the properties of the derivative, right? Now it is the property of the derivative. So this is nothing but grad of f plus this is nothing but grad of g. Okay, grad of g. Or if you want to write the, instead of the summation you write x, y, z, no issue. Or you may suppose ask that grad of f plus g. We may write it summation of I del by del x plus summation, sorry, no need to write the summation, I write the entire thing here, f j del by del y plus k del by del z f plus g. Now it is the properties of the derivative. It is I del by del x plus j del by del y plus k del by del z f plus similarly I del by del x plus j del by del y plus k del by del z g. Okay, so this is equal to here grad f plus grad g. So it is better to write like this, it is better, right? The symbolic form, or in short what writing, this is in short. Okay, this is in short. So now coming to the proof of 2, suppose, or I suppose proof 3, it is del fg. So this will be what, summation of I del by del x fg. Now this is the simply the properties of the derivative here. Okay, so I write it summation of I, here the properties of the derivative. Okay, here f del by del x g plus g del by del x f, right? So this is equal to, you can write summation of I del g by del x f plus summation of I del f by del x g. In that way I write, right? I write this. So this will be here, this is grad f, this is grad g, and this is f, plus this is grad f and this is g. Or I can write f grad g plus g grad f, or if I want to write f, put a vector notation, then also okay, g grad f, because grad f is itself a vector. Okay, so we may write like this. Now coming to the proof of 2 is similar, proof of 3 I done, then proof of 4. So coming to the proof 4 here grad f to the power n. So you can write it summation of I cap dot del by del x of f to the power n. Now derivative of f to the power n, this is summation I n into f to the power n minus 1. Because of the chain rule, it is again here del f by del x. Okay, so this is taken out, nf to the power n minus 1 summation of I del f by del x. Okay, because so here this is nothing but grad f, so this is nf to the power n minus 1 here grad of f. Likewise you prove the others. So now let us solve some examples. Suppose you are asked to, given the scalar point function f, you are asked to find grad f and grad f at a particular point. So coming to the solution, so what is your gradient of f? It is fxi plus fyj plus fzk. So now partial derivative of f with respect to x, it is it is here 4xyz square. Okay, so this is I, and with respect to y again it is here 2x square z square plus 6y j. Now again if we differentiate with respect to k, with respect to z, it will 4x square y z k. Okay, so now what is grad f at the particular point? At the point 2 0 1, you put x2 y0 and z1. Okay, so it is 0i plus here it is becomes 0 6 xz, it is here 8j, and it is here 0k. So this is equal to 8j only. Okay, coming to one more example. Suppose you are given a vector point function, you are asked to find div v and call v. We will discuss details the div and call in the next lecture, but here what is your div v? Div v is del v1 by del x plus del v2 by del y plus del v3 by del z. Simply it is my v1, it is my v2, it is my v3. So del v1 by del x will be, it is here 4xy plus it will be here, sorry, so del, it is with respect to x, yes, it is here with respect to x, it is 4xy plus it is with respect to y plus 3 plus it is 0, so it is 4xy plus 3. So now div v at the point 2 3 4, so it is 4 into 2 into 3 plus 3, so it is a 27. Okay, similarly if you are asked to find curl of v, curl of v means here I j k, del by del x, del by del y, del by del z, here fx fy fz. Okay, fx fy fz, you have to find the determinant of this. Sorry, it is v1 v2 v3, sorry, it is v1 v2 v3. Okay, it is v1 v2 v3. So I can substitute I j k del by del x, del by del y, del by del z, and here v1 is 2x square y and it is here 3y plus 5. Now simply you evaluate the determinant. So it is I kf into del by del y of 5 minus del by del z of this. Okay, 0 minus 0 minus j kf into here del by del x of 5 minus del by del z of this is 0 plus here k kf into, okay, here k kf into this and this omitted, it is del by del x of this 0 minus del by del y of this 2x square. So this is equal to minus 2x square k. Now here call v at the point here 2 3 4, 2 3 4. So this is equal to minus 4k. Okay, sorry, so this is 4 into 2 minus 8k. So this is your answer. Okay, now coming to some more examples. Coming to another example, you are given r is a scalar, it should be a scalar. Okay, r is modulus of r in rq, and you find grad r and del square r and del r to the power n. So what is your r? Now here r, what is r? R is in 3 dimension, it is xi plus yj plus zk, xi plus yj plus zk. What is magnitude of r? It is x square plus y square plus z square root over. Now it is a scalar now. Okay, now it is a scalar now, right? Now this is scalar r, scalar, right? This is your scalar. So now what is your rx? Rx is, it is 2x divided by root over of 2 x square plus y square plus z square. This 2 cancel. I can write it x by, this is again my modulus of r. It is again my modulus of r. Similarly, what is my ry? ry will be 2y divided by 2 into root over of x square plus y square plus z square. So it is again y by modulus of r. Similarly, what is rz? Rz is z by modulus of r. So therefore, what is grad r? Grad r is here rxi plus ryj plus rzk. So I can write it. It is 1 by r mod taken common. It is xi plus yj plus zk. So it is again my vector r. So this is equal to vector r by magnitude of vector r. Okay, or I can write it r cap, right? So this del r is a scalar, but entire del r is a vector. Now coming to your del square r. Del square r means it is del r. Del r is a vector here. Okay, so with this del r, it is a vector, so here it is dot. So I can write it. So I can write it. It is I del by del x plus j del by del y plus k del by del z, right? Del by del z, and del r is here rxi plus ryj plus rzk. Now you see, now it is nothing but the dot product, means it's behave like the div, right? Means we can see it is div of del r in that way, right? So this is I dot i1 j dot j1 k dot k1, right? So it is rxx plus ryy plus rzz. Okay, we have to find rxx. So what is your rx? So this is rx is x by root over of this. Here rx is x by root over of x square plus y square plus z square. Similarly, you find rxx, double derivative, del by del x of this. Okay, and similarly you find ryy. Similarly you find rzz. You note that if rx is equal to, sorry, if your del square f is equal to 0, right, then it satisfy Laplace equation. Then it satisfy Laplace equation, right? Actually, if I simplify it here, then it will give me, y square plus z square divided by x square plus y square plus z square to the power 3 by 2. Okay, similarly here it will be x square plus z square divided by this x square plus y square plus z square to the power 3 by 2, likewise this. And if I substitute all this thing here, and this will give me 2 by root over of x square plus y square plus z square. It is here 2 by r. So the answer here will be, here del square r will be 2 by r. Okay, you can have your details of your work. The video is getting lengthy, we should close it here. So here we have discussed the vector differential operator nabla, and using this we define gradient, divergence and curl. However, the divergence and curl will be discussed in separate lectures with all details, and moreover the applications of gradient in the upcoming lecture. I shall discuss the application of gradient, application of grad, geometrical interpretation, and the one of the most important thing is the directional derivative. Okay, so these are the most important aspect which will be discussed in the subsequent lecture. So if you feel this lecture is useful and interesting for you, please like and subscribe to this channel, which will boost my motivation. So we should close the lecture here. Thank you all. Have a nice day.